Size does matter in this industry. Sometimes it takes a dozen specialists to create such a micro-cooler. Gaps between various components of a module must not exceed 100 microns, which is less than the diameter of a human hair. When RMT entered the market 20 years ago, no one could have imagined that such devices could exist in reality. This is one of RMT's unique developments, a thermoelectric module with a cooling power density of 40 watts per square centimeter. It was thought until recently that given the size of the device, its power must be 2.5 times less. Many fail to understand what a facility for manufacturing such modules should look like. Russian company RMT receives more than half of its orders from the United States. The company can start its day by making micro-coolers and finish it by manufacturing, say, heat flux sensors. When one type of product comes off the assembly line, a new order is already being processed at the start of the production chain. You only need to run the appropriate program. Neither weather nor a human factor can affect the device. It's designed to work at the same capacity. In other words, when we changed it to computer-aided manufacturing, we can schedule our production down to the exact day and hour. RMT specialists admit that the path towards such a design concept was twisty. Modules acquired new characteristics due to original orders, when only 2 or 3 unique micro-coolers needed to be produced. This is how the idea of automatic hyperdense assembly came about. This TE module looks no different than any other device in the RMT lineup. However, on the inside, it's the other way around. It is a sort of reverse microcooler. It generates electricity as soon as the temperature difference reaches a few degrees. This green energy harvesting solution makes it possible to produce energy even from the warmth of human hands. They are enough to power such gadgets as cardiac pacemakers, which normally work until the battery goes flat, 2 years after they place it in you. A patient then needs to undergo surgery, but now we can use this solution, and due to the difference between body temperature and ambient temperature, electricity is generated. The company is gradually making its way into sectors where no one knew it would be needed. Russia is currently producing heat flux sensors that are several times as sensitive as foreign-made sensors. These are fully self-contained, self-calibrating devices. If a heat flux sensor is incorporated with a TE generator, the combination will work for more than 30 years without maintenance. The most amazing thing is that we manufacture these devices by drawing upon technology that we developed in our own company. The same material, similar operating procedures, etc. But it can be applied in a much broader context. RMT manufacturing capacity now allows to produce about 10 million thermoelectric modules per year, and in any required configuration. For this, RMT developed a special program that finds the optimal configuration by checking hundreds of thousands of solutions in less than a minute. The module may acquire any shape, size, and the desired properties. It may have advanced protective coating that allows to operate in high humidity or in aggressive ambience. It may be a party in 1 million products and 2 or 3 unique customized modules. This technological breakthrough at the Russian company had an unusual effect. RMT is working almost entirely for Western customers. 90% of its products are sold via dealerships in Germany and China. RMT is a rare case, in that it is the West that has become the largest consumer of Russian nanotechnologies.